Okay, ladies and gentlemen, we're continuing with section 2.1 in Math 1033. Part 1 has already been created for you. Now you're on section 2.1. This is the second part of that lesson. I want you to look at the cursor. We're asked to graph the function f of x is equal to 3x minus 5, and we're asked to do it by plotting points. Now, some of you in the past have been taught the formula y equals mx plus b, and you've been taught to graph using the slope-intercept method. We will get to that later on in the course, I promise. In fact, that's an excellent method. But right now, let's follow directions. Graph this line by plotting points. Now, the reason I know this is a line is because x is raised to the first power. And anytime you're graphing a function of degree 1, you're going to get a line. So I picked some very simple values for x. And the reason I'm only choosing 2 points is because to graph a line, if you can find 2 points that lie on it, you can connect those 2 points with a ruler, and then you have the entire line. Some of you, I believe, in the past have been taught to graph to put 3 points in your ordered pair table. That third ordered pair is simply sort of a check and balance to make sure that you didn't make a mistake with the first 2. But it's not necessary. If I put in a 0 for x, 3 times 0 is 0, 0 minus 5 is negative 5. That creates the ordered pair 0, negative 5. If I put in a 1 for x, and again I'm using very simple numbers, it's your choice. If I put in a 1 for x, 3 times 1 is 3. 3 minus 5 is negative 2. Therefore, I've created 2 ordered pairs. Follow me. Where the cursor is flashing right now is the ordered pair 0, negative 5. Where I'm now moving the cursor to is the ordered pair 1, negative 2. X is 1, y is negative 2. And we now take out a ruler and we connect the 2 points and we have our entire line. Why is f of x called a linear function? Well, first of all, anytime you have a linear function, the graph will be a straight line. A way again that you knew this was going to be a linear function, that x was raised to the first power. A first degree function and a linear function are the same. You always expect the graph to be a line. Also, let me remind you, some of you again have been taught f of x, which is the same as y, equals mx plus b. This formula in your past courses has been called the slope-intercept formula, and we'll get into that a lot more in the course as the course progresses. But right now, one way to graph linear functions is by plotting points. Now, the next function you're given here, the function f of x is equal to the opposite of x squared plus 4. The minute I know, or the minute I see that the degree of this function is 2, the minute I see that we have a function of degree 2, I know that my graph is going to be a parabola. And let's just not talk math for a while. Let's just kind of talk very, kind of gut level. A parabola, the kind of parabolas that we work with, they almost look like a horseshoe curve, either opening up or opening down. Okay? So those are the main ones we're going to start with. So the reason I know this graph is going to be a parabola, i.e. a horseshoe-looking thing, is because it's degree 2. This also answers the question why it's not a linear function. It's not linear because it's degree 2. And one association I want you to start making, anytime you have a function whose degree is 2, your associated graph is going to be a parabola, either opening up or opening down. One further clue I'd like to give you, if the number in front of the x squared term is negative, the graph will open down. If the number in front of the x squared term is positive, it opens up. Now, what I want you to notice here, I definitely plotted more points than I did for a line, and the general rule of thumb is this. To graph a linear function, 2 points are all that's really required. But once you start going to a higher degree, and what I mean by that in this case, a second degree, you definitely want to get more points so that you get the correct shape. Okay? A parabola is a little bit more complicated to graph than a line. You need to pick more points. Now notice I chose very simple values. I chose a 0, a 1, a 2, a -1, a -2. So a good rule of thumb is put in 0, put in some positives, put in some negatives. Now when I put in a 0, that's very easy. 0 squared is 0, the opposite of 0, 0. 0 plus 4 is 4. When I put in a 1, now pay very close attention to this. When I put in a 1, the x value is 1. So notice I put it in parens with a squared on top of it and then a plus 4. The minus sign stays on the outside because x was 1. 1 squared is 1. The opposite of 1 is -1. -1 plus 4 is 3. I'm doing the same thing now for the number 2. Notice the 2 goes in parens and that's being squared, but the minus stays in front. Very important when you're plugging into a function that you put the x value in parens. Look what happens. 2 squared is 4. The opposite of 4 is -4. -4 plus 4 is 0. Come down here with me. When I put in a -1, we have the opposite of -1 quantity squared. Notice my input goes in parens, and then of course the plus 4. Okay, check this out. -1 quantity squared is 1, but then the minus in front makes it -1. -1 plus 4 is 3. And the same deal down here. The opposite of a -2 quantity squared plus 4. -2 quantity squared is 4, but the minus in front makes it -4. -4 plus 4 is 0. So I have some ordered pairs to graph. Okay, here's the ordered pair 0, 4. Here is the ordered pair 1, 3. Here is the ordered pair 2, 0. Here is the ordered pair -1, 3. Here is the ordered pair -2, 0. And now it's kind of like those little things you did when you were a kid. You connect the dots. I've already told you that a second degree function is going to be a parabola, sort of a horseshoe. This one opens down, so you connect the dots. You make it sort of a U-shaped graph opening down. And the reason I put arrows is because this graph continues to go down. It doesn't stop. So there's your introduction to graphing parabolas. Okay? All right. And let's see what we're going to do here. I think what I'm going to do, I'm going to go ahead and pick this up on the next video for section 2.1. So let's cut it right here with a linear graph and a parabolic graph, and I'll return to this in a moment on your next video. Thank you.